MCA Prep Day 4. Our first benchmark, 8231. Evaluate algebraic expressions, including expressions containing radicals and absolute values at specified values of their variables. Remember that radicals are square roots, so they're talking about evaluating square roots, and then absolute values. Remember that the absolute value is the distance from 0 on a number line. And because it's a distance is always a positive. So for example, the absolute value of 5 is 5. The absolute value of negative 5 is also 5. Both of those numbers are 5 units away from 0 on a number line. So distance is always positive. And those two straight bars, that's what represents absolute value. So the first problem up here says, evaluate each expression for x equals negative 3 and y equals 7. So x equals negative 3 and y equals 7. So for my first one, if x is negative 3 and y is 7, this is what the problem would look like. Because they have their own absolute value bars around each number, I'm going to evaluate them separately. The absolute value of negative 3 is 3. And the absolute value of 7 is 7. And then because there's a minus sign in between them, 3 minus 7 is negative 4. So that's our answer. On part B, you may notice that it's one expression in absolute value bars, and that expression is x minus y. So if I plug in negative 3 where the x is and 7 where the y is, it's now one expression. Negative 3 minus 7 is negative 10. And the absolute value of negative 10 is positive 10. So what they're showing you is that having two separate sets of absolute value bars around the x and y versus one set around the x and y when they're being subtracted makes a difference in your answer. Our second benchmark, 8232, says justify steps in generating equivalent expressions by identifying the properties used, including the properties of algebra. Properties include the associative property, commutative property, and distributive property, and the order of operations, including grouping symbols. Use the expression, parentheses, x plus y, parentheses, plus z. And part A says use the commutative property of addition to write an equivalent expression. Part B, use the associative property of addition to write an equivalent expression. Well, the commutative property, what helps me remember the commutative property is that the C and O at the beginning tell me that I need to change the order. So on this problem, I will be changing the order of my addition. The commutative property works for adding, and it also works for multiplying. So you may notice that this initial problem has two different addition symbols. So I am going to rewrite this two different ways to show you how the commutative property can work. So the first one, I'm going to change the order of what's being added in parentheses, and it would look like this. Or if I instead switch the order of the addition outside of the parentheses, then it would look like this. So either one of these would be correct in using the commutative property to rewrite an equivalent expression. So changing the order of two things, two quantities that are being added together. Next up, we have the associative property. I remember this because Who you associate with is like who you hang out with in your group. So associate is like your group. And so your group or grouping symbol is the parentheses. So you're changing your group with the associative property or moving the parentheses. So instead of being around the X and the Y, you move them so that they're around the Y and the Z instead. That's the associative property. Our next benchmark is 8241. Use linear equations to represent situations involving a constant rate of change, including proportional and non-proportional relationships. Remember that proportional goes through the origin, non-proportional does not go through the origin. So that would have a different intercept. So if it goes through the origin, that means the y-intercept is 0. If it's non-proportional, the y-intercept is something other than 0. It does not go through the origin. So part A, we have a phone service provider that charges 10 cents per minute used. Write an equation that represents the total cost C for m minutes used. Remember, when you write an equation, the pieces that you need for this equation, you're going to need variable, or in this situation, 2 variables. We need an equal sign, and we typically need math operations in there and numbers. So letters, numbers, math operations, and an equal sign. So this equation is a basic one. The total cost equals, it's 10 cents per minute, so I just need 10 cents times m. C equals 10 cents times m. So this one is proportional. This one is proportional. They weren't asking for that, but in reading the benchmark up above, I just want to point that out. This is proportional. The y-intercept would be 0. There's not a starting point. It's just a flat rate of 10 cents per minute. So that's a constant rate of change. Another company charges $8 per month and 3 cents per minute used. Write an equation that represents the total cost C for m minutes used. So same variables. This one is charging 3 cents per minute. So I'm going to attach my letter M to that 3 cents because you would multiply. That's our constant rate of change. But I need to add on $8 for this one because you're paying the $8 per month and then getting the cheaper rate per minute. So this one is non-proportional because of that starting rate of $8 for the month. Our next benchmark is 8242. Solve multi-step equations in one variable. Solve for one variable in a multivariable equation in terms of the other variables. Justify the steps by identifying the properties of equalities used. Part A, so number 1, solve the equation 3x minus 5 equals 7. Part A, show the first step towards solving the equation. What property did you use? Well, to get the variable by itself, I would first add 5 on each side. So that would leave me with 3x equals 12. And because I added on each side, that's called the addition property of equality. Adding the same number on each side. The next step, so part B, solve the equation, what property did you use? The next step, I would need to divide by 3 on each side. So that would leave me with our final answer, x equals 4. Because I divided on each side, that would be the division property of equality. Reading this benchmark at the top, another thing that it's talking about when it says solve for one variable in a multivariable equation in terms of the other variables. Remember, those are the ones that look like formulas, like A equals BH, area equals the base times the height. So you might have to solve for a different variable, like it might say solve for the letter B. So if you need to get the letter B by itself, I would divide by the H because they're right next to each other. So dividing by h would leave me with the area divided by the height equals the base for this particular formula. So these are called literal equations, and literal equations are trickier because of multiple variables being in them. But you use the same properties as solving equations with a lot of numbers in them. So it's the same skill set. Our next benchmark is 8243. Express linear equations in slope-intercept, point-slope, and standard forms, and convert between these forms. Given sufficient information, find an equation of a line. So, point-slope, okay, let's see. So slope-intercept, these are all on your formula sheet for your MCA. Slope-intercept is y equals mx plus b, where m is your slope and b is your y-intercept. Point-slope is y minus y1 equals m times x minus x1 in parentheses. Remember, m is still the slope of your line, and x1, y1 represent 1 point on that line. And then standard form is ax plus by equals c. And remember that a has to be a whole number, and b and c have to be integers. So no fractions or decimals are allowed, and the order is very picky. On all of these forms, they're written in a specific order, but this one in particular, you have to have the x, the y, the equal sign, then the plain number. Okay, so what's the equation for the line in point-slope form? So point-slope form, y minus, so my slope is m, my point is x1 and y1. So y minus negative 3 equals 2/3 x minus 4 would be my equation. So minus negative at the beginning is a chunky plus. So simplified, my equation is y plus 3 equals 2/3 times x minus 4. Now, standard form, this is very tricky. Very, very, very tricky. So I'm going to take this equation that's in point slope, and I am going to simplify this to get it into standard form. The first thing that I need to do is take the 2/3 and distribute it. So I distribute 2/3 times x is 2/3 x. 2/3 times 4, or negative 4. If I put a 1 under it, I would get 8/3, like that. Then, because no fractions are allowed in standard form, I see the denominators. On the bottom of each fraction, I see a 3. I'm going to multiply this whole entire thing by 3 to clear those fractions. So whatever number you see in the denominator, the bottom of the fraction, that's what you need to multiply by, because multiplying by it will cancel it out. So I multiply everything, and I get 3y plus 9. So don't forget, you've got to multiply the left and right-hand sides. Then 3 times 2/3. That will cancel out the denominator and leave just the 2x. 3 times 8/3, again, cancels the denominator, leaves just the 8. Now, we've gotten rid of our fractions. Now we've got to deal with the picky order over here. Ax plus by equals c. So my x is clearly on the wrong side, so I need to move it to get it in the correct spot. So that's like subtracting 2x on each side. So if I subtract 2x on each side, I cancel it out, and I get negative 2x plus 3y plus 9 equals negative 8. Okay, now, because we've got our picky order over here, I can't have this 9 on the left-hand side, so I need to subtract this 9 to get rid of it. So that will leave me with negative 2x plus 3y equals negative 17. And then, because a has to be a whole number, a can't be a negative, I am going to have to multiply everything by negative 1 so that that x becomes instead a positive 2x, And that will change all of the other signs like this. So my final answer is 2x minus 3y equals 17, because standard form is so picky, so picky. And that was our last benchmark for today.